Hey all, welcome to the series of design and analysis of algorithms. And today's topic is divide and conquer. So first let's discuss what is divide and conquer. Then we'll see how divide and conquer works, and then we'll see some of the applications of it. And coming to what is divide and conquer. So basically it is a strategy, or you can say it is a method to solve a problem. So whenever a problem is given, so we'll approach that problem to solve it by using some techniques, right? So this is one of the strategies used for solving a problem. Okay, and what kind of problem can be solved by using this divide and conquer, or where it is very much useful means whenever we have a problem which is of larger in size, then we can break that problem into smaller sub problems, and then we'll go for solving that sub problems and then combining the results of the sub problems to get the desired outcome. So this is how a divide and conquer strategy works. So the name itself says you are going to divide and then you are going to conquer it. So there are two steps in this divide and conquer strategy. First is divide and the second one is conquer. So in the divide only you are going to divide the given problem into smaller sub problems, and then the sub problems will be solved recursively. So after solving all those sub problems, the results will be combined, and then the original result or the desired output for the original problem are retrieved from that conquer step. So for example, if we are given with a problem called P, okay, so I need to solve this problem P somehow. So here I'm going to use divide and conquer strategy. So how divide and conquer strategy works? So the given problem is divided into sub problems. Okay, so you are dividing the problems into sub problems like problem 1, problem 2, problem 3, problem 4. So these are all the sub problems of this problem P, right? And then you are going to solve the sub problem and finding the solution for it. So for each and every sub problem we have a separate solution, and then you are going to combine all the solution to derive the final solution, that is S for this original problem P. So if in case your problem P1 is also of larger size, then what you can do is again you can subdivide this P1, right? So based on the size of the problem you can divide the problems. Okay, based on the problem you are going to divide the problem, and then you are finding the solution for every sub part of the program. Then the solution will be combined together to form the actual solution, right? This is how a divide and conquer algorithm, the divide and conquer strategy works. So we'll see the general algorithm for this divide and conquer strategy. This is the general method, that is general algorithm. So this is divide and conquer, and you are given with a problem. So when this problem is given, what you're basically doing, you need to check the size of the problem. So if the size of the problem is small, okay, then you are directly going to find the solution for the given problem, right? But in case if the problem is a larger problem, then what you're going to do, you're going to divide that problem P into smaller sub instances, that is sub problems. So P1, P2 up to Pk. So here the condition is K value should be greater than or equal to 1, because when you are dividing a problem, that problem should be divided such that each and every sub problem should contain at least one element in it to solve, right? So that is the condition given here. The K value should be greater than or equal to 1. And after dividing the smaller instances, then you're going to apply this divide and conquer algorithm again, which means you're going to call this method once again. So in order to solve these sub problems. Okay, so this is what the recursive call. Every time you are applying the divide and conquer call. Okay, so once these sub problems are solved, then the solution will be combined here. So here you can see the combine. So you are going to combine the solution of every sub problems. So this is how the general method works. Now let's see how to find the time complexity for the general algorithm, that is divide and conquer. Coming to time complexity. So when you want to find the time complexity, you need to go for recurrence relation. So how to find the recurrence relation of an algorithm? So here recurrence relation indicates how much time taken to execute the statements of your algorithm. Okay, so this is the recurrence relation for the algorithm, that is divide and conquer. Here there are two cases you can see. In first case, if the value of n is small, that is if the problem is of smaller size, then directly we are going to find the solution for that problem. So that time taken to find the solution for that smaller problem is given as g of n. So here g of n is the function which indicates the time to complete the answer directly for smaller inputs, right? What if the input is larger? Okay, then that is the second case. If the input is larger, what we will do basically? We will divide the problem. After dividing the problem, then we'll go for finding the solution and then combining the solution. This is what the larger problem will get executed. So if you look at the larger problem, for example P, this problem will first divided into smaller sub problem. So after finding the sub problem, again you need to check the size of the sub problems. That is, this process will happen recursively until the size of the problem becomes small, right? So this is how the algorithm works. In the same way, now you have to check this problem P1, size of the problem, and then again go for subdividing it if the problem size is large. Okay, the same way you're going to do for the next problem. Again you have to check for this problem, then you need to subdivide if it's necessary. So likewise you are going to do the same process repeatedly until the size, all the size of this problem becomes small. Okay, so when you are trying to divide this problem, you can see this problem is first divided into two problems, and then again this problem is divided into two problems. This is also divided into two problems. Likewise you are splitting the problem into two divisions. So that is why it is given as t into n divided by 2. So which means totally two divisions happening here. So this represents the time taken to process these sub problems, okay, to find the solution for these sub problems. That is what given here. This is the time taken to find the solution for the sub problem. I'm coming to f of n. This is a function, okay, and this function represents the time that is taken to divide the sub problem, divide the problem into sub problem and then combining the solutions of the sub problem. Right? So how much time it is taking to divide and combine, that is given by this function f of n. Now based on this recurrence relation, we'll be finding the time complexity. Coming to time complexity, there are two ways to find the time complexity when you have a recurrence relation. Okay, the first way is by using a substitution method. Okay, we have the first method, that is substitution method, and the second method is by applying Master's theorem. So we'll discuss what are all these methods. Coming to substitution method, again the substitution method can be done in two ways. One is forward substitution and the second one is backward substitution, right? And so when we are going for a substitution method, you need to do some mathematical calculations there by substituting values in it. And coming to Master's theorem, so here we'll first discuss what is Master's theorem, how it can be applied, okay, and what are the cases, right? And we will be using Master's theorem to solve this recurrence relation, okay? And this is the Master's theorem, okay, and you can relate this with our recurrence relation for divide and conquer method, right? So if you look at here, we have coefficient a, then t of n divided by b plus f of n. So here our our recurrence relation is 2 into t of n divided by 2 plus f of n, right? This is what our recurrence relation for divide and conquer general method, and this is the Master's theorem. So here you can see all the similarities between these two recurrence relations, right? Because of this only, for divide and conquer method, we are going to apply this Master's theorem in order to solve and find the time complexity. And coming to the cases here, so here you can see there are three cases to find the time complexity. That is the first case, when a value is lesser than b power d, then the time complexity would be theta of n power d. And coming to the next case, a is equal to b power d, then the time complexity is theta of n power d log n. And again the same, a is greater than b power d, then the time complexity would be n power log base b a. Right? So these three are the cases. By using, by checking this condition, we are going to finalize what is the time complexity of the algorithm, particular algorithm, when it is in this format. Right? And coming to f of n, as I mentioned earlier, f of n is the time taken to divide and combine. Right? So here this can be given as theta of n power d. Okay, so whatever is there in the power, that will be given as, the value will be taken as d, constant d. Okay, and here the coefficient is taken as a, and here the whichever is in the divisor, that is taken as b value. Right? So here is an example. This is our recurrence relation, and this is a, value of a is 2, and this is b, value of b is 2, and coming to f of n, so the value of f of n is 1, which means some term, it is not just 2, okay, it can be any constant value power 0. That is what will gives you the value 1. Now what is the value of d? So this is the format for f of n, that is n power d. Here n value I have taken as c, and what is the power? That is 0. Now this power is considered as the d value. So what is the value of d? That is 0. We know the value of a, we know value of b, and we know the value of d. By using these values, we can find it comes under which case. Okay, so the value of a is 2. And then value of b is 2. We need to find b power d. So what is the value of b power d? D value is 0. What is 2 power 0? That is 1. So now we are going to compare this value with this value. So here a value is greater than this value, that is b power d. Right? So which is a third case. If you see here, a is greater than b power d. This is a third case. So if it is third case, and what can be the time complexity? theta of n log a base b. So here theta of n log base b a, which is equal to, what is the value of n? So n value we do not know. So let it be n, and applying the value of a and b. So if you apply the value of a and b, so that is log 1. Value of log 1 is, log 2. The value of log 2 is 1. So if that is the case, then finally we'll retrieve the time complexity as theta of n. So this is how we need to find the time complexity for the recurrence relation, which is in the form of Master's theorem.